Good morning, good afternoon, everyone. Thank you for joining us today for the Microservices Security Summer Camp Session 2. We're going to be talking about best practices today for microservices security. So we started with the introduction, and that is now available online on demand if you happen to miss it. Just go to tigera.io/webinars, and you can see it in the lower right-hand corner of the screen as a link. Today we're going to talk about best practices and about how to secure your microservices environment. And in a couple of weeks, we're going to talk about, based on those best practices, how do you evaluate a solution to put in place. Our camp counselor for today is Christopher Lillian Stolpe. He was the original architect behind Tigera's Project Calico, which many of you may know about. He speaks for Tigera at around 60 meetups per year. I think he's doing around 14 or something this month. So you might have seen him around. He speaks about networking and network security for these modern applications. He also is our chief consultant here, helps our clients secure their modern applications. And as a fact, he was actually a park ranger at one point in time.
All right. Again, welcome everyone. As Andy said, I actually was a park ranger in the National Park Service at one time, and I think the most humorous line I got to say was pulling up to someone and who had a flat tire in the park or whatever, and saying that, "Hi, I'm from the government and I'm here to help you." And that usually would be everyone would get a chuckle out of that. So I'm not from the government anymore. I'm from Tigera, but I'm here to help. Let's have a little bit of a talk about microservices security. And as Andy pointed out, a couple days ago, we talked about an introduction. What's changed in the microservices world? Why microservices are going to change the way you think about security in your environment. And we raised some challenges, some things that have changed that might make current practice for InfoSec have to at least reassess the way they go about you go about solving problems or solving these challenges. So I'm just going to go over what some of these challenges are. One of the things we talked about in the earlier session was code provenance. Basically, it's no longer just your vendor's code or code you wrote in-house. Code could be coming from many different places. It could be that your developers are writing glue code that's sticking open source projects together. You could still get vendor code or homegrown code. Your developers, though, could be writing that code using libraries and modules drawn from a huge number of resources and repositories. So how do you know what code you're using? People think about scanning for known CVEs, for static code analysis to make sure that the code that you're bringing in from elsewhere follows reasonable practice. And you need to do all of that, of course. Is the repository even where you're getting that code from trustworthy? One thing I don't think a lot of people think about is license contamination. If you have your developers going out and pulling code from all sorts of different resources because it allows them to get their job done quicker, how are you managing the fact that you might be having code coming in with many different licenses? And maybe you have a corporate policy that certain types of code can't use, say, GPL or Oracle open source or some other open source license or licensing construct. If you're doing this automatically and all your developers are pulling code, how are you going to know you're meeting that requirement? So you need to start thinking about not just the safety of the code, but the legal safety of the code. Automated deployment, for good or ill. As we said earlier, manual waterfall process isn't going to cut it. If you want to be responsive and agile, going through a waterfall process that might take you weeks to get code pushed is not really going to meet the business demand. So you start looking at automation, and automation is great, except you can also automate a disaster. One of the terms you use is, are you going to automate a flatline event for your business by pushing something really bad that tanks the entire service? So you need to start thinking about, you want to automate things, but automate things in such a way that there are circuit breakers and other things in place that will prevent you from doing a large amount of damage with an automated process. You might want to think about that as blast radius containment. Tweaking or patching code. To date, most times when I discover I've got a problem in the code or I need to address a CVE, I'll log into the server and I'll make the change to the server, to their running environment. That's not immutable. One of the things we talked about in the previous session was that the cloud native pattern is immutability. That what I push, what I commit will always be the same. So if you got people logging in to edit running servers or running services, etc., that's not immutable. It's not recreatable. So you need to think differently about how you're going to do this to make sure things are always immutable, always repeatable. One of the worst things you can do is have somebody log in and tweak one instance, for example, of, say, a container because it's got a problem or they're trying to troubleshoot something. And let's say they do that, and then you get a scaling event. And the orchestrator fires up 499 more of those containers to handle the scaling event. Well, the orchestrator is not going to know about the fix you made to the one running container. It's going to fork off 499 more of the things that you committed into the repo, into the GitHub or whatever. So guess what? You're going to have one thing, one pet out of a herd of 500 cattle that's doing something different. Trying to figure out that failure mode, why it fails one in every 500 times for a customer is not going to be particularly an enjoyable experience. So you really need to either, I'm going to treat everything as cattle or everything as pets. Don't mix pets and cattle in the same field. You're going to have problems. The other thing to keep in mind, if it doesn't exist in Git, it doesn't exist, or whatever you're using for source code control. Do not push things or commit things that aren't in whatever you're using as your repository of record. It makes it almost impossible to trace where things came from, what things are running, etc. So if it doesn't exist in Git, it just doesn't exist. Some more challenges. Changes in the anchor. As we said, these are very ephemeral environments, and they're very rapidly changing environments. IP address is not an identity anymore. What the identity of the workload is metadata and labels. We'll talk about that a bit. It's no longer possible to use an IP either to anchor policies to, nor as a pointer that you are, as an indicator that you were in compliance, because IP addresses are completely ephemeral. Blast radius. We now have a very large infrastructure. It's very dynamic. Perimeter security is necessary, but it's no longer sufficient. If you elect to have just a perimeter security, you have to assume in this kind of dynamic environment, you will have the opposition get past that perimeter security. Myriad ways that can happen. Once you're in, there's no way to control lateral movement. You're already in the front door, and I have no locks on the interior doors. A common phrase in the industry or a statement in the industry is there's two types of organizations: those that have an advanced persistent threat and those that don't, or know that they have an advanced persistent threat and those that don't. If you rely on perimeter security, those advanced persistent threats, which you do have in your organization, will have free reign. And that's a bit of a problem. And a corollary to that is an explosion in east-west traffic. Basically, what used to be function calls within a monolithic application are now API calls over the network. The network is now the interconnection bus for the components of your microservices. So where you used to have 95% of your traffic going north-south, but from queries from your users and responses to those queries, with maybe 5% traffic going east-west in the data center, that is now inverted. And now the vast majority of traffic within your cluster is actually east-west traffic, not traffic that is actually responding directly to or receiving instructions from an end user. As a general rule, that east-west traffic is now not logged. So that means that 95% of your traffic is opaque. That also is going to be a bit of a problem when it comes time for compliance, because you're not actually recording most of the stuff that's happening in your infrastructure. Infrastructure as code. Your infrastructure can now be managed just like your application code base. Policies, service discovery, or service exposure, storage mounting, etc. All of this, storage setup, all of this is now, even server configurations themselves, are all now code artifacts. The good thing is you can use that same CI/CD pipeline to manage your infrastructure just like you manage your applications. The negative to this is that conversation we had earlier about automating disaster. If you make a change to infrastructure and commit the code and it automatically deploys to 5,000 servers and it was wrong, that will be a bad day. So you need to figure out the same care you use for managing how your applications get pushed. You should administer that care or more in the way you push infrastructure. All of these things relate back to changes that can happen in seconds. Can you react in the same time frame manually? Odds are probably not. And if you can, even if you try and react manually to a problem, by the time you figured out what's going on, the event has already ended, or worse yet, has morphed into something else. So you'll be playing a catch-up game trying to catch up with this automated system that is now off the rails. So you need to take a step back and start thinking about how you're going to automatically respond to issues. Go back and find what's actually the problem and fix it at root, and let automation take care of cleaning it up rather than you trying to keep ahead of an incident. So let's take a look at some of the best practices now. So we're going to talk a little bit about infrastructure hardening, registry and container scanning, intent-based models, segmentation and policies, multiple enforcement points and layers, TLS, RBAC and audit, and meaningful logging. And the key word here is meaningful logging. So infrastructure and hardening. Key thing here, containers bring their own things they need to execute. You do not need to have all code known to man, all capabilities known to man in the servers that the container is running on. So if you don't absolutely need it, don't install it or don't enable it. Basically, keep this stripped down as much as possible, your underlying infrastructure. The containers will bring with them what they need. Keep it simple. This is a corollary to the first one. Simple makes it easy to assess if your hardening is correct, etc. It makes it operationally easier, but just keep it simple. Automate security patch application. You don't want to go around and hand patch every server when Patch Tuesday comes around or whatever you're using equivalent thereof. The folks at CoreOS, now Red Hat, had a really good mechanism for automating deployment of operating system updates. Other folks have explored the same area. Investing in something like that is a real winner. And you might think that having automated deployments of operating system updates would be problematic because your servers are going to be rebooting. But remember that orchestrator that you put in place assumes that servers are going to die and will just assume that a server rebooting because of an OS update is just another server failure, and it will gracefully handle those. You won't see an interruption in service. So automate that security patch applications. Otherwise, you will end up like certain credit rating bureaus. Use mandatory access controls in the kernel, and by this we mean things like AppArmor, SE Linux, etc. Not root doesn't need to be able to control everything on a server. So, a concept of least privilege, only allow entities that should have specific access to those capabilities within the kernel. So this is good practice. Don't allow direct CLI access to your infrastructure unless you're an extremist. You should, and this goes back also to immutability and repeatability. If somebody logs in, makes a patch to a server to get it working again, they're going to forget to check that back in. They're forget to apply it to other servers. Now you have one server that's different from all the others, and things are going to start breaking, and it's going to be difficult to trace why. So don't treat any piece of infrastructure as a pet. If you need to fix something, go back, fix it in the manifests, and then push the change. Don't SSH into these things. And you might want to consider a management and control plane isolated network for things like the control plane for the orchestrator, et cetera, putting that on your management network, your admin management network, or at least using some form of host isolation policies to control who can get access to that actual orchestration control plane. And ship your logs and manage your clocks. Logging on a server is not going to do you any good if that server goes south, either because of an attack or because of an outage. So your logs have to go somewhere where you can look at them. A corollary of that, make sure everyone has the same clock, the same concept of time. It is going to be impossible in a fleet of thousands of servers and hundreds of thousands of endpoints to figure out what actually happened if everything has even slightly different concepts of time. So deploy NTP, etc., but make sure everyone's chiming to the same clock. And that way it gives you the ability to correlate events across multiple endpoints. Container registry and scanning. Any containers in your registry of records should be scanned on every commit and fingerprinted. You could be using Docker Hub, you could be using Quay, you could be using any of the other registries, but make sure that things are scanned every time an update's made and that they're fingerprinted. Scan for CVEs. Scan for libraries or inclusions you don't want. Maybe you don't want a specific version of Java for whatever reason, then make sure that you scan to make sure that things checked into that registry don't include those libraries. License leakage, I referred to this earlier. Maybe you have a policy that for production code that has corporate intellectual property, you don't want, say, GPL licenses. You might, LGPL is fine, but GPL is not. So you want to make sure that you're scanning for GPL code in those modules. Containers and artifacts that don't have a matching fingerprint should be scanned as part of the CI/CD. So if you've got a container, an artifact that's part of a manifest, and the CI/CD chain is building it, and it matches a fingerprint of something that's already been scanned, you know it's good, let it go through. If it doesn't have a matching fingerprint, then you need to scan it at CI/CD at the integration time. And then hopefully check that back in and register the fingerprint. But you need to make sure that things have been scanned before they go out the door. Let's talk a little bit about intent models. The system should allow you to express your intent as to how it should behave rather than telling it what to render or what to do. Bob should not be able to send LDAP traffic to Alice should be the way you express your intent, not a specific IP address allows LDAP traffic from another specific IP address, because guess what? In a couple of seconds, those IP addresses will be different. So you really want to have this more as a intent. I don't care if there's a Bob or an Alice, but if there's a Bob or an Alice, this is the way they should behave. Another example, EU backend should be able to connect to EU databases, but not US databases. Not, again, based on exactly what network rules I want to put in place. This is a high-level intent. It makes it easier to understand later what you were trying to do, and it makes it easier for the orchestration system to actually render something that does what you want it to do versus trying to second-guess what you were trying to accomplish because you were using ephemeral data as an anchor for a policy. This goes for more than just network policy and security. We talk about network and policy and security here in Tigera, but this applies to things across the board, from storage to service exposure, etc. Intent is the way you should be managing these environments. You should not have multiple segmentation mechanisms, i.e. coarse and fine grain. Coke can't talk to Coke, Pepsi can, and Coke can talk to Coke, Pepsi can talk to Pepsi. It's a coarse grain policy. Fine grain policy, front ends in Europe can only talk to back ends in Germany. That's more of a fine grain policy. Problem is, those aren't binary, and that's going to be that's an analog distinction between 0 and 1, which means you will never always make the same guess. Should I do this in the coarse model or the fine grain model? And which means at 3 o'clock in the morning, when it's broken, you will be confused as to what you did and why. Similarly, what's coarse today, Coke can talk to Coke, Pepsi can talk to Pepsi. Tomorrow is going to be fine grain because there's going to be other requirements that come on board. But if you model that relationship in a coarse grain model that can't do fine, you have to unmodel it on one side and model it on the other side. Again, you're introducing chance for confusion and misconfiguration. Workloads should be able to belong to multiple disjunct topologies without interference or coupling. If you use, say, VLANs to say Coke can talk to Coke and Pepsi can talk to Pepsi, what about the thing in Coke that needs to talk to something in Pepsi? There's a myriad of things where I have multiple relationships on the workload, not a single relationship. And I need to be able to support all those relationships in a policy model. Policy should define a capability or a personality, not a specific workload. Don't write your policies thinking this workload needs these rules, because the next time somebody ships the next version of that workload, it might need a different set of rules. Instead, think in terms of personalities or characteristics. This thing is an LDAP server. This thing is an LDAP client. LDAP server should be able to receive traffic from LDAP clients. This thing is a PCI compliant front end. It should be able to talk to things that are PCI compliant back ends. Those are capabilities or personalities. And then a given workload might be a LDAP client and a PCI enabled back end. The same capability might map to multiple disjunct workloads, and the same workload may map to multiple capabilities. So this allows you to mix and match, and as code evolves over time, you can adjust those policy mappings just by saying this thing is now an LDAP client. It wasn't before, but now I'm having my backend do an LDAP query, so now it's an LDAP client as well. In a zero trust model, you probably shouldn't put all of your trust in just one point. What's the point of saying I have no trust if I'm saying I actually have absolute trust in just one point? And it's not a zero trust model. It's a one trust model. Multiple point bookended enforcement is very hard to subvert in an at-scale dynamic environment. I won't necessarily go into the details on why, unless we get a question. But if the opposition can do something to subvert bookended, i.e. ingress-egress policies at multiple layers in your infrastructure, say at TLS at layer 5 through 7 and at layer 3, 4, then they already own your infrastructure at such a deep level that this is pretty much an academic discussion. In order to do this, they already have all the keys to the kingdom they need to take over your infrastructure anyway. You have a bigger problem, in other words. Different layers have different metadata and other characteristics that have meaning. The relationships between those constellations are a very high quality signal to base policy on. If I say that Bob's should be able to get cust records from things started with a cust record, do gets on URLs that start with cust record from Alice, that is an interesting data point. If I say that these TLS certs tied to this user service account can make queries to things with this service account, that is another interesting and disjunct piece of signal. And then I say Bob's can talk to Alice's on 443, that's a third signal. So I now have a network layer, I have an encryption layer, and I have an application layer bit of signal. I put those three together and I have a very clear and distinct fingerprint of what should be happening between Bob and Alice. And I can now tie a policy to that allows that to happen versus just keying off one bit of metadata. I can now make these decisions based on multiple independent pieces of metadata from different layers in the stack. Love MTLS, don't fear it. I know that a lot of folks out there are scared about what's going to happen when all their applications are encrypted. They're not going to be able to do any traffic analysis or DPI on their traffic. Everything's going to be encrypted TLS. However, TLS is a wonderful identity layer. It gives you pretty good surety that the identity of the computing peers are the ones that you think they are, and it's transitive across multiple transports. I don't care if you crossed 5 NAT gateways between A and B. If someone hasn't terminated the TLS, you actually still have a pretty good identity if you're using mutual TLS and client-side authentication and server-side authentication, that the two endpoints that are talking are the two endpoints you think are talking. This is a very, very powerful construct. So use MTLS. What that means, so as I said, I have non-repudiation, authentication, and secrecy come along in the bargain. So I know who sent it. I was able to authenticate them based on that, and I've actually provided some privacy for the data flow as well. It will play hell with your middle box DPI, however. There's a way of solving that, which means give the DPI box all the TLS keys and have it decrypt and re-encrypt in the middle. What you've just done is given a ready-made man-in-the-middle attack to all those APTs you have in your infrastructure. You've given that middle box all the keys to your kingdom. So you might secure it, but it's a really juicy target. The opposition's smarter than you, smarter than all of us. They will get onto that. And remember we talked about minimizing the blast radius. This is more like maximizing the blast radius. This is not a good idea, folks. Don't do it. So what you probably want to do is do this inspection before or after TLS. Don't break the chain. So one of the nice things, you can look at Istio. Istio does this encryption directly adjacent to the workload. The keys are shared or saved just within the workload. Blast radius is minimized, and Istio will expose a lot of this DPI capabilities natively to you before it gets encrypted. So you minimize the blast radius, you don't share keys and around, and you still get DPI while you get strong TLS security. RBAC and audit. Role-based authentication, control, and audit. Remember that blast radius? Please don't give one set of individuals all the keys. There shouldn't be someone who, if you have this concept of super user or, in router terms, privilege level 15 user for your entire infrastructure, that's going to end really, really poorly. You probably do need, for every component, a get out of jail free card. Things have gone horribly, horribly wrong. We need to get into the platform. Those credentials should be unique to each platform or even each instance of the platform. And they should be locked up physically in a safe and inspected, if you ask my opinion, or some electronic version thereof. Users should not have access to those keys unless, it's break glass here problem. Normally, people should have access, and applications and code should have access to just do what they need to do for their specific function. Audit logs just aren't for HR action. You're going to not only want to use them in case somebody did something bad, figuring out who that was and as part of an investigation. You also just want to know who's doing things and why. And it could be the system changed, maybe for good, maybe for bad. You don't know why it was done. You want to find out who did that change and ask them. You may, as an operations team, want to see how people are interacting with the system and see if there's things that you can automate. This is a good signal for seeing how people actually use your system. So audit logs tied to users and therefore their roles, be it an automated user, i.e. piece of software, or a real user, give you a lot of good understanding about how the platform is being used. It's not just for persecuting somebody, it also might be for making the system better. So these are all important characteristics. The system should tie into a site-wide RBAC. You don't want a YAS. You don't want yet another authentication system. If you have separate, disparate authentication systems, you will forget to update them after those HR actions. And again, it will all be over but the screaming. So you should have a common RBAC authentication model, repository, be that LDAP, be that Radius, be that Active Directory, be that whatever you want to use. But it should be common, and you should have everything tie into that. So there's one point to administer who can do what in your system. That's a good place to put the guy with the gun and lock it lock it behind locked doors and motion sensors, et cetera, because that is a bit of a sort of place bomb here thing. But in this case, centralizing that data dramatically outweighs the secure disadvantages of doing so. Audit log should be immutable and non-reputable. I want to make sure that what's in the log actually happened, was signed by the thing that injected the log, and then I can tell, preferably no one should be able to change those logs, but if they change them, I at least want to know that they've been changed. I need to know that they're no longer reliable, but really you want them to be you want them to be immutable. So if you don't have those two things, you don't really have an audit log. You have a nice fictional piece of text that might make you feel good, but it's not a log. It's definitely not an audit log. They need to capture both human and machine actions. Most of the actions in your infrastructure are going to be machine-driven. They're not going to be human-driven. You need to capture what the machines are doing as well as what the humans are doing. Remember Skynet from the movies? Yeah, you want to know what the machines are doing. Let's take a look at logging in general. Logs are not only good for forensics and break-fix input, but they also show a trend of behaviors over time that can inform on the health of the system and what you might want to optimize. Everything still may be going great, but in the logs you see that over time my APIs are degrading and taking longer and longer to respond. Maybe I need to look at fixing that before it becomes a break-fix problem. Or I never intended for that API to be called as frequently as it's being called. I thought it was going to be an uncommon use, and it's being used all the time. Why is that? Let me go find out why people are using that. Should I redesign that API to be more efficient because it's being used more frequently? Or should I go figure out why people are using this API? Maybe I need to go fix the thing that they're trying to work around. And then again, that could be a machine or a human. So this gives you lots of feedback on how your system's being used, not just on its overall health. So these things are pretty useful for more than just break-fix. Again, broken record, non-reputable, and immutable. I want to make sure that what's in there is what was put in there and then hasn't been changed after hit the log. Those two things are slightly different, folks. One is I want to know that the thing that went in the log, the message that went into the log came from the thing that's authoritative for knowing what should be going in the log, i.e. The output of an API call. Logging should be coming from the thing that should be able to generate that. Somebody can't go in and just fake that. Secondly, once it's in the log, I want to make sure that the log hasn't been changed. So that's, the first is non-reputability, the second is immutability. So you want to make those two things go together, but they are slightly different. Logs should be searchable and retain any meaning as they slide back in history. If you're using an IP address as a key in a log, it's going to be useless if those IP addresses are recycled every few hours or less. Yes, 4 hours ago, 191.51.100.37 did something bad. I have no idea at this point in time who 191.51.100.37 is. It's now that address is being used by something else. So you need to start using something else to be able to make these logs be usable and meaningful. In a microservice environment, that's metadata, that's labels, that's Git commit IDs. There's all sorts of things that go into the things that are identifiers within a metadata system. They're just not IPs, host names, etc. really. So that metadata itself should be a key in the logs, not something ephemeral like an IP address or a host, etc. Logging systems should be able to trigger alerts based on thresholds. In a large system, you will always have a run rate or background noise level of alerting. If you don't do something to mute those, you will go crazy responding. A good example, I was at a large bank very early on in the days of firewalls, and I got called in to help them with their firewall installation. And the previous contractor had installed something called a deck talker, which was a serial device that would read text over a serial line and speak it out. It was actually what was used by Hawking early on when he would talk. It was a deck talker early on. This guy had wired up a deck talker to the firewall, and every time the firewall got any policy hit, it would scream out, "Help, help, I'm under attack." And I was in that data center, and there was nothing but this constant scream of "Help, help, I'm under attack" coming from the firewall. Obviously, other than the 5 minutes of humor value versus, and after 5 minutes, one take a hammer to the darn thing. The more important thing was it's always going off, so no one's paying attention to it anymore. So you need to be able to set thresholds. Some events are more important than others. Some are only more important when they hit a certain threshold. So you should be able to mute and trigger alerts based on threshold events. And you should be able to integrate your logging system into larger logging systems, not yet another logging system. There's no use in having yet another pane of glass to look at yet another set of logs. You won't be able to correlate the logs between different types of events anyway. So your logging systems that you pick should all cooperate and dump into the same place where you can do correlation, etc. So with that, thank you for your attention. We've got a little bit of time for Q&A, but I'll turn it back over to Andy here.